Now, if you want to assign label manually, we can do like this. For example, on R1, if you notice, show MPLS forwarding table, we have labels 17, 18, 19, 20, 21, 23. I want to tell the router that it can use labels in between 25 to 50 or 25 to 75. I don't want this to use these labels, for example. I want it to use from 25 onwards. How can we do that? This is how we do. MPLS label range. I can say start using from 25 to 50. And now already label is assigned, right? So because label is already assigned, what we have to do is we have to cancel the MPLS globally. So interface level I am not cancelling, it's still there. But I'm killing the MPLS process so that I can restart the process. It's like in OSPF we used to say, no, clear IP OSPF process. Same likewise. We say no MPLS IP, and then I put MPLS IP back. Now if you see, show MPLS forwarding table, you see label starting from 25. Alright, let me do it one more time. On router 3, listen carefully. And on router 3, I want to say the label starting from 300. So I say MPLS label range 300 to 325. Clear. No need to say clear. Best is this. No MPLS IP. And then put MPLS IP. Now if you notice, show MPLS forwarding table. You can see in this router, the labels are starting from 300. Are you comfortable? Did you understand what I said? Yes. Okay. We learned in the previous class the difference between no label and pop label. For the directly connected, label number 3 will be used and that will be advertised. So that the neighbor router will do PHP, penultimate hop popping. So that there is no need for two lookups, MPLS, again IP. For example, router 1 is advertising label number 3. So router 2, any packet to 1.1.1.1, it forwards to router 1 without MPLS. Likewise, router 3 is advertising 3333 M and so on. Any question? Next is the advanced level of MPLS. So for whatever you have learned is MPLS. But MPLS along with BGP can be used to do VPNs. Mostly people will use this VPN whenever they have MPLS. And service provider only uses MPLS most of the time. They definitely have BGP, and they definitely do this VPN. Why do you need VPN? The best reason why we need VPN is I no need to run BGP full mesh. I no need to use configuration. I no need to use route reflector. Sometimes we use route reflector even when we have BGP. When you have hub and spoke design, we will use one route reflector, not more than one. When we don't have VPN, this is the problem, right? We have to enable BGP on every single router. Otherwise, you will not be able to ping from alpha to beta. You won't be able to ping. Why? Only when you enable BGP on all the routers inside, those routes of west and east appears in the routing table. But when we do VPN, you don't need BGP on all routers. It's a very big advantage. You just enable BGP on R1 and R4 and put a VPN. So now there is no need for BGP on all the internal routers. See, in here you may have just two routers as the internal router. But in the production you will have many. Yeah. So forming this tunnel with the help of IBGP. So you're going to form IBGP between R1 and R4. We are going to form IBGP between R1 and R4. Using that IBGP, we are going to have an additional address family called VPN v4. VPN v4 is a channel negotiation using BGP. Yeah, under BGP, we go and negotiate tunnel. And we will have a VPN. So that take the customer route. You take the customer route, put it inside the VPN tunnel. It goes and then appears here, and then it goes there. Best advantage. You no need to have BGP on the middle routers. But in the real world, we got many customers. Here I have customer west and east. In the real world, to this provider edge router, we'll have many customers like customer A west, customer A east. Now, each customer will advertise some network. Now, that network need to be distributed through the tunnel. For example, this guy is advertising alpha. This guy is advertising omega. This guy is advertising beta. This guy is advertising Omicron. Now, this omega should not go to beta. Omega should go to east, CA. CA east, not CE east. Likewise, beta should not come to CA west. So this separation of customers route need to be taken care by the same BGP. Can BGP do this? Yes. BGP does this by using extended attributes. Extended attributes called community. Yeah. It's not the community that you learned in the early BGP class. There you did everything manual. Here it is automatic. BGP is going to use the community attribute to keep the customer's traffic getting mixed from one another. To make it clear, I want to give you another example. Alpha is Alpha is Burger King. Company Burger King in west, Burger King in east. This Omega and Omicron, they are from McDonald's. MD West, MD East. They both are not same company. You'll get burger in both the places. But they both are not from same. They're not same company. Two different companies, right? Now, you don't want Burger King to get into MD and MD to get into Burger King. You don't want this to happen. Not only that, you don't want this Burger King coming to this MD, nor this Burger King going to this MD. You don't want any of this mistake. The tunnel is one, but you want total isolation between these two vendors. You're providing service to these two vendors, and you want total isolation between Burger King and McDonald's. How can you provide this? BGP with MPLS can do this. How? Along with VRF. VRF is nothing but the tunnel endpoint. VRF stands for Virtual Route and Forwarding. Forwarding. For you to understand, I'm going to tell you like this. When you create VRF, it is like you create a separate control plane and a separate tunnel. See, Actually, it is only one tunnel. But by creating VRF, you split this tunnel. For each customer, there is going to be a separate tunnel. Why I say separate tunnel? Because BGP is going to use separate route target values to maintain. So it becomes like two tunnels. Like this. See, this is for your understanding I'm doing. Don't expect this while configuring. When you configure, you will be configuring only one tunnel. When you configure, you only negotiate and form one tunnel. But when you create VRF, in VRF, we specify different encapsulation for these customers. VPN is nothing but encapsulation. So this BK will have one route target, MD will have another route target. That forms two VPN. Not only that, here locally on the router, you get two separate routing table. One for Burger King, another for McDonald's. With this link as a member. This is McDonald link, this is Burger King link. So VRF helps you to create a separate routing table, virtual routers or virtual routing table, a separate control plane, and that is connected to this tunnel, not to the physical link inside the service provider, but to the tunnel that is inside the service provider. So whatever Burger King advertises, it only goes and delivered to this Burger King here. Whatever McDonald's advertise, that goes and delivers only to the McDonald routing table here. So VRF helps to have more than one control plane in a single router. Usually, routers will have only one routing table, only one control plane. Yeah. So VRF is nothing but creating multiple routing tables, one for each customer. And when you create VPN, VRF becomes the part of VPN. Understand this very well. VRF becomes the part of VPN. That's the open, that's the mouth of the VPN. All VRF will be part of this VPN. And this VPN has got two small openings, one for BK and one for MD. And BK gets a separate encapsulation called route target, and MD gets another encapsulation, extended BGP community value called route target, that helps to form two separate tunnel. Even though they are going to share one common VPN, Burger King and McDonald's are not going to get mixed. They will not get mixed because inside the tunnel they have a ID to keep them separate. Inside the tunnel, the routers that is handling the traffic knows that this belong to Burger King, that belong to MD, McDonald's. Ask me question, please. So when you create VRF, you need to specify two things. Number one, route distinguisher. Number two, route target. Each VRF needs these two things, route distinguisher and route target. Route distinguisher is a 64-bit value. Route target is also another 64-bit value. Route distinguisher is local. Route target is global, meaning route target is attached to the network. For example, if this West is advertising 1111, inside the tunnel, that West will be seen 1.1.1.1 route target. This is how it will look like. MD also have got 1.1.1.1. Inside the tunnel, it will look like this: 1.1.1.1. MD is route target. They are not same. For example, if MD is route target is 200:200, this is how it looks. Here it is 10:10. This is how it looks. So even though the network is the 1.1.1.1, meaning MD is also selling chicken burger. Burger King is also selling chicken burger. When it comes through the tunnel, how do you differentiate this? This is from Burger King, that is from McDonald's. There is a label on the packet. The label is 10:10 for Burger King, 200:200 for McDonald's. So that will not get confused inside. And this will go here, and this will go here. That is route target. Route target, see the word is given very nicely. Target helps to know to whom to deliver. With the help of the target value, you know that it needs to be delivered to the Burger King on the east. If it is 10:10. If it is 200:200, it needs to be delivered to McDonald's on the west. Yeah. So route targets are helping to do this. Do you want McDonald's? Yeah. So route targets helps to identify the remote edge router and the VRF to which it needs to be delivered. Whereas route distinguisher locally helps to differentiate between the Burger King and the McDonald's. Locally, to know who send these advertisements. to know who has sent these advertisements, the route distinguisher is used. See, the word clearly says route distinguisher, distinguishing the route. Right, so the route distinguisher is 64-bit, route target is 64-bit. It is separated like this: 32-bit colon 32-bit. This can be autonomous system number of the customer. This can be the IP address of the customer, or it can be simply a number like this: 10:10. Basically, this is what going to be used as an ID of the customer. And here also you can say 100:100. This becomes the ID to differentiate through the tunnel. This is to differentiate locally. This is to differentiate the routes over the tunnel. Route target. Route target is what? This value is what we call it as a BGP, extended community values, for the customer. When you create VRF, automatically this BGP community gets configured. You no need to configure community. You no need to configure community. It gets configured automatically. Any question? Let us do a quick lab on this. See, we are going to now create VRF. Today just we'll create one VRF and then we'll form VPN and we'll try to ping between west to east. Right now on R1 we are running OSPF in this customer facing interface, which I'm going to remove. This I'm going to remove. I'm going to say default interface F01. This will cancel all configuration from that interface except no shutdown. Show IP OSPF interface brief. Do I have OSPF on customer facing interface? No, not at all. I'm trying to create the real world scenario now. Even on R4, I say default interface F01. Done. Show IP OSPF interface brief. So if OSPF is not running here, you know very well this ping won't happen. Which ping from east to west won't happen. Show IP route, you won't have routes in first place. Alright, what is next? Let us put IP address on customer west on this interface, customer east and west. So on the west, I'm going to say F00, 200, 200, 201. We are not going to enable any routing protocol now. And I don't want any OSPF. There's no OSPF. Focus Understand, if you have question, you should ask. Customer Edge East don't have any routing protocol. It has got just one IP address on F00. So show IP route will have the directly connected 200, nothing more. Likewise on the east, sorry, this is on the east. Likewise on the west, interface F00 100.0.0.1 done. Show IP protocol. I see there is a OSPF running. I'm going to remove it. No router remove OSPF. Show IP protocol. There should not be any protocol now. There is no protocol. Show IP route. It should have only the directly connected. Okay, it has also got a loopback. No problem. We have a loopback. Let me mention this on the screen so that tomorrow when we extend this lab, it will be useful. Also on this side, I would like to add another loopback. This all will help us to do more testing. I will say 220. So going to the east router to add one more loopback. All right. Okay, so two connected networks you have, one on fast Ethernet 00, one on loopback. Now you know very well that I will not be able to ping this because there is no route. And you also know that I don't have any IP address on the customer facing interface. Right now, I don't have this IP address here. The reason why I removed that IP address from there is that interface, I'm going to make it as a member of another routing table, which I'll be creating for the customer using VRF. How do we do that? I'll go to router 1 and show you. Right now, when I type show IP route VRF all, VRF star means all. You don't see more than one routing table. This is the only routing table we have right now. But I'm going to create a VRF routing table, one for this customer. This is how we create. IP VRF, and the name you can give, I want to say cust, right? Or maybe tomorrow we will be using more customers, so better we'll give customer 1. All right, I'm going to say IP VRF cust Burger King. all the routes coming from and going to Burger King, I want it to be identified with route distinguisher. I told you route distinguisher is 64-bit, 32-bit colon 32-bit. The 32-bit can be AS number and some number, or it can be IP address of the customer or IP address on any one of the interface towards the customer and an IP, or it can be any number like this. Your wish. I want to give 1:1 for customer Burger King. As I told you, this is locally significant. I can give the same route distinguisher on another router for another customer. That won't impact. For another customer on another router, I can give the same number 1:1. But you cannot mess with route target. For this customer, I'm going to say route target 1:1. See, that is also 64-bit. I'm just going to give 1:1. Is it mandatory to match with the route distinguisher? No, not really. This is basic VRF VPN lab. So I'm doing it basic. I don't want to make it more complicated. We'll talk about more complicated things, import value, export value, all the stories later. Let's go simple first, so that you will get the concept well. So far, what we have created is a VRF. The command to verify is show IP VRF. We gave a name and we have configured route distinguisher. Where is the target? If you want to see the target, you need to say detail. This is the route target. I gave 1:1. That has become for both export and import. Again, I'm telling you, don't ask question on import and export today. I said we'll see that next. This is basic. First, understand the concept. What is route target? What is route distinguisher? You should be clear with this terminology and where it is used, how it is used. Now, what is missing is the interface. This this VRF don't have a interface. It's like you created a VLAN and you did not assign any interface to the VLAN. VLAN is layer 2, this is layer 3. So now which interface we want to assign it to that VRF? F01. So we have to go under F01 and say, hey, you are a member of this VRF. IP VRF forwarding customer Burger King. Only after putting this interface into that VLAN, that VRF, you should assign IP address. Don't do in the other way. If you put IP address first and then the VRF membership, that won't work. It will remove the IP address. First, assign the interface to a VRF. And then give IP address. The IP address as per the plan is 100.00.10/8. 100.00.10.255. Done. Now, if you go and check the routing table, you will have two routing tables. You see, this is global routing table, and you see this is another routing table for that customer that you created, and that has got this interface as a member. Okay. Similarly, I'll go to router 4 side and configure. IP VRF Cust Burger King. The name doesn't matter. It is locally significant. Doesn't need to be same on every provider edge. Route distinguisher also doesn't matter. There I gave 1:1. Here I'm giving 10:10. Nothing wrong. But route target should be same. I told you this is what will be used in the tunnel. Next. Interface F01, IPVRF forwarding, cust BK, and then put the IP address. 200.0.0.10, 255.255.255.0. Finished. What is next? Next is the VPN. All right. Next is the VPN. We are going to use BGP 100 autonomous system. Now I'm on router 4, router BGP 100. Address family IP VPN v4 unicast. Neighbor is 1.1.1.1. This is the loopback address of router 1. Remote AS. Wait a minute. First of all, we have to do this. We have to do IBGP. Neighbor is 1.1.1.1. Remote AS 100. Neighbor 1.1.1.1. Update source loopback 0. And then you need to go under address family VPN v4 unicast. And then neighbor 1.1.1.1 activate. That's it. Just activate. Yeah. Similarly, on router 1, router BGP 100, neighbor 4.4.4.4, remote AS is 100, address family VPN v4 unicast, all right, and then neighbor 4.4.4.4 activate. Now you will see VPN also coming up. One neighbor has already come up. Now this is another neighbor, session 2. This is for the VPN. VPN is ready, VRF is ready. Now what is not ready? What is not ready is the route advertisement from the customer to the provider and provider to the customer. So I'm going to put this in BGP 10. This is in BGP 20. And what we are going to do is we are going to advertise using BGP. I'll say router BGP 20. I'm in the west. You got a neighbor called 200.0.0.10. Remote AS is 100. Second thing is I want to advertise 220.100.100.100.
The router BGP10 one.
I'm on east. Oh, okay. I'm on west. Sorry. Correct. No router BGP 20. Thank you. Router BGP 10. I'm on the west. Okay, I'm in the west. I thought I'm in the east. Okay, neighbor is 100.0.0.10. Remote AS is 100. Network 110.100.100.100.25 mask. Show IPBGP. Okay, we are advertising this. I also want to advertise the connector network, router BGP 10, network 100.0.0.0. Done. Now going to router 1 to form EBGP. Very important place now. You see, this interface is not a member of global routing table. It's a member of VRF. So when you form neighbor, it should be from VRF table. So we say router BGP 100 address family IPv4 VRF cust-bk. This is what the VRF name we gave. From here we need to say neighbor 100.0.0.1. Remote AS is 10. Now you will see neighbor coming up. See, neighbor has come up with a customer via VRF. Similarly, router BGP 100 neighbor is address family IPv4 VRF cust-bk. Neighbor is 200.0.0.1. Remote AS is 20. Now going to the east. Router BGP 20. Neighbor is 200.0.0.10. Remote AS is 100. Network that I want to advertise is 220.100.100.100. Mask 255.255.255. It's 32 mask, not 24. That is all. I have finished. And you know very well these two middle routers don't have any BGP configuration there. If you want, you can check. Go to router 2 and check show IP BGP, not active. Also check on router 3, show IP BGP, not active. But if you go to west or east, show IP route, you can see the route coming from the west. And you will be able to ping without a problem. Source, I have to source it with loopback. Let me go to, I'm in west, no? Okay, I'm in east. I'll go to west. Show IP route. I have, oh, there's no route here. Something is wrong with western side. Show IP BGP. I do have BGP. I'm advertising this. Show IP BGP summary. I even have neighbor. But why nothing is learned? What is wrong? No prefixes learned. Let me go and check on the east. I think east is not advertising. Show IP BGP. It is learning from the West, but locally nothing is advertised. Show run interface loopback 0. Okay, here it is 24. That's the problem. I was advertising 32. Okay. Now you will find, go to West and check. You have learned the prefix. You will be able to ping now this one. Ping this one. With the source of your loopback, the ping goes. Okay. This is what MPLS Layer 3 VPN. I don't know how much you got it.